You're watching EduSpot. Learn smarter, understand faster. Let's begin.
Have you ever wondered how your phone unlocks by recognizing your face? Or how YouTube recommends videos you enjoy? How ChatGPT understands your questions, or how self-driving cars recognize roads and traffic signs? These technologies are powered by one of the most advanced fields of artificial intelligence called deep learning. Today, we'll learn deep learning from scratch. No prior knowledge of programming or AI is needed. I'll explain every concept using simple language, real-life examples, and easy animations. By the end of this lesson, you'll understand what deep learning is, how it works, why it's so powerful, and where it's used in the real world. So, let's begin our journey into one of the most exciting technologies shaping our future. Before learning deep learning, let's understand what it means. Deep learning is a branch of machine learning. Machine learning allows computers to learn from data instead of following fixed instructions. Deep learning takes this idea further by using large artificial neural networks inspired by the human brain. Imagine teaching a child to recognize a cat. Instead of giving many rules, you simply show thousands of cat pictures. After seeing enough examples, the child naturally learns what a cat looks like. Deep learning works the same way. Instead of being programmed with every rule, it learns patterns directly from data. The more quality data it receives, the better it becomes at making predictions. That's why deep learning is one of the most powerful technologies in artificial intelligence.
Deep learning is a subset of machine learning and artificial intelligence. A computer can learn by looking at thousands of cat pictures. The neural network processes the data and correctly labels it cat.
Many beginners get confused between artificial intelligence, machine learning, and deep learning. Let's make it simple. Artificial intelligence, or AI, is the largest field. Its goal is to make machines behave intelligently. Inside AI comes machine learning, which teaches computers to learn from data instead of being programmed for every task. Inside machine learning comes deep learning. Deep learning uses artificial neural networks with many layers to solve complex problems. Think of it as three circles. The largest circle is artificial intelligence. Inside it is machine learning, and inside machine learning is deep learning. Every deep learning system is part of machine learning, and every machine learning system belongs to artificial intelligence. Understanding this relationship is important because these terms are related, but they are not the same. What is an artificial neuron? Now that we know what deep learning is, let's understand its smallest building block, the artificial neuron. An artificial neuron is a simple mathematical unit inspired by neurons in the human brain. Your brain contains billions of neurons that receive information, process it, and send signals to other neurons. Deep learning follows the same idea. An artificial neuron receives inputs, processes them, and produces an output. Imagine you're deciding whether to carry an umbrella. You think about three things. Is it cloudy? Is rain expected? Is the wind strong? These are your inputs. Your brain combines this information and makes a decision. If rain is likely, the output is simple: take the umbrella. Artificial neurons work the same way. They collect information, process it, and make a decision. One neuron is very simple, but millions working together can recognize faces, translate languages, and understand speech.
Let's understand the layers of AI. Artificial intelligence includes robot assistants. Machine learning powers spam filters. Deep learning enables face recognition.
What is a neural network? A single neuron can perform only a small task. To solve bigger problems, many neurons are connected together. This system is called a neural network. Think about a football team. One player cannot win a match alone. But when 11 players work together, the team becomes much stronger. The same idea applies to deep learning. Thousands of neurons work together as one network. Each neuron performs a small calculation, and together they help the computer make accurate predictions. For example, imagine the computer is recognizing a cat. Some neurons detect edges, others detect ears. Some recognize eyes. Others identify whiskers and the tail. Finally, the network combines all this information and confidently says, "This is a cat." Each neuron contributes a small piece of information, but together they produce an intelligent answer. That is the true power of a neural network.
A single neuron is small and weak, but many neurons connect with glowing blue lines. The digital network grows larger. When a cat image enters, highlight to identify features.
Every neural network has three main parts. The first is the input layer. This is where the data enters the network. For example, if we want the computer to recognize a handwritten number, the image first enters the input layer. Next come one or more hidden layers. These layers perform most of the learning. The first hidden layer may detect simple lines. The second combines those lines into shapes. The third recognizes complete objects or meaningful patterns. Finally, the information reaches the output layer, which gives the final answer. For example, the image is the number 7, or this picture contains a dog, or this email is spam. The hidden layers are why it's called deep learning. The more hidden layers a network has, the more complex patterns it can learn. Now comes an interesting question. How does deep learning actually learn? Imagine teaching a child to recognize apples and oranges. At first, the child makes mistakes and may call an orange an apple. You correct the mistake and show more examples. Gradually, the child learns the difference. Deep learning works the same way. First, we collect a large data set. For example, imagine 50,000 pictures of cats and 50,000 pictures of dogs. Each image has the correct label. The computer studies these images one by one. At first, its predictions are often wrong. After each prediction, it compares the result with the correct answer and adjusts itself slightly. This process repeats thousands or even millions of times. With enough practice, the model becomes highly accurate. Just like humans improve through practice, deep learning improves by learning from its mistakes.
The cat image enters the neural network. Layer 1 highlights the edges. Layer 2 simplifies shapes. Layer 3 defines complex features like eyes with high confidence.
Let's see what happens inside a neural network when an image enters. This process is called forward propagation. Suppose we give the network a picture of a cat. The image enters the input layer. Then the information moves through each hidden layer. Every neuron performs a small calculation. Each layer extracts more useful features. The first layer detects edges. The second detects shapes. The third recognizes eyes, ears, and whiskers. Finally, the information reaches the output layer, where the network makes its prediction. For example, there is a 92% chance this image is a cat. This complete journey, from input to output, is called forward propagation. It is simply the process of passing information through the network to make a prediction. What happens if the prediction is wrong? This is where two important concepts come in, loss function and backpropagation. The loss function measures how wrong the prediction is. Imagine the network sees a picture of a dog but predicts cat. Since the correct answer is dog, the prediction is wrong. The loss function calculates the size of this error. A bigger mistake means higher loss. A smaller mistake means lower loss. Now comes backpropagation. It sends the error backward through the network. Each neuron adjusts its internal values slightly to reduce future mistakes. Think of a student checking an exam. After finding the wrong answers, the student studies those topics again and performs better next time. Deep learning works the same way. Every mistake helps the model improve. This cycle repeats until the network becomes highly accurate. So far, we've learned that neurons receive information, process it, and produce an output. But should every neuron always pass its output to the next layer? The answer is no. Before passing information forward, each neuron makes a small decision using an activation function. Think of it as a gate or a switch. Imagine you clap your hands in a room. A smart light sensor decides whether the lights should turn on. If the room is already bright, nothing changes. The sensor acts only when needed. Activation functions work the same way. They decide whether the information is important enough to move to the next neuron. This helps the network focus on useful patterns and ignore unnecessary information. There are many activation functions, but beginners only need to remember 3. 1 is ReLU, the most commonly used. 2 is sigmoid, often used for yes or no predictions. And 3 is softmax, which selects one answer from many possible options. You don't need to memorize the formulas right now. Just remember that activation functions help the network make smarter decisions.
Now a single neuron receives multiple signals. An activation function acts like a gate. It allows strong signals to pass through, while blocking weak signals.
Learning doesn't happen in a single attempt. The model must go through the training data many times. Each complete pass through the dataset is called an epoch. Imagine you're preparing for an exam. You don't study your book just once. You revise it again and again. With every revision, your understanding improves. Deep learning follows the same process. During the first epoch, the model makes many mistakes. In later epochs, it gradually improves. As training continues, the model becomes more accurate. However, training for too many epochs can create a problem. The model may memorize the training data instead of learning general patterns. This problem is called overfitting. A good deep learning model learns patterns that also work on new, unseen data. Choosing the right number of epochs is an important part of training an AI model.
As training continues over multiple epochs, accuracy improves. But training for too many epochs can cause overfitting. The model memorizes exact images instead of learning patterns, failing to generalize.
Deep learning is not just one model. There are different types of neural networks, each designed for specific tasks. The first is the convolutional neural network, or CNN. CNNs are excellent at understanding images. They are used in face recognition, medical image analysis, and self-driving cars. The second is the recurrent neural network, or RNN. RNNs work with sequential data such as speech, handwriting, and time series information. They remember previous information while processing new data. The third and most advanced type is the transformer. Transformers understand relationships between words and information very efficiently. Modern AI systems like ChatGPT use transformer-based models to understand and generate human language. Although each model is designed for different tasks, they all belong to the deep learning family.
CNNs are used for computer vision tasks like face recognition. RNNs process sequential data such as speech and handwriting. Transformers excel at language translation and to deep learning.
Now that you understand how deep learning works, let's see where it's used in everyday life. You may already be using deep learning without realizing it. When your phone unlocks using your face, deep learning recognizes your facial features. When YouTube or Netflix recommends videos, it analyzes your viewing patterns. When Google Translate converts one language into another, deep learning helps understand the meaning of sentences. Doctors use it to detect diseases from X-rays, CT scans, and MRI images. Banks use it to detect suspicious transactions and reduce fraud. Modern cars recognize roads, traffic signs, pedestrians, and other vehicles using deep learning. Virtual assistants understand spoken language and respond naturally because of it. From healthcare and education to finance and entertainment, deep learning has become an important part of our daily lives.
It unlocks your phone, it recommends videos, it translates languages, it assists doctors, it detects fraud, it drives cars, it responds to voice, all powered by deep learning.
Deep learning has transformed many industries, but like every technology, it has both strengths and limitations. Some of its biggest advantages are, it can learn from very large amounts of data. It solves complex problems with high accuracy. It improves as it receives better training data. However, there are also some limitations. Training deep learning models requires a huge amount of data. It also needs powerful computers, especially GPUs, which can be expensive. Another challenge is that many deep learning models are difficult to explain, making them a black box in some situations. Understanding both the advantages and limitations helps us use this technology more effectively and responsibly. Congratulations! You have completed a beginner-friendly introduction to deep learning. Let's quickly review what we learned today. We started by understanding what deep learning is and how it fits within artificial intelligence and machine learning. Then we explored artificial neurons, neural networks, and the input, hidden, and output layers. Next, we learned how deep learning improves through training using forward propagation, loss functions, and backpropagation. We also discussed activation functions, epochs, and overfitting. Finally, we explored different deep learning models like CNNs, RNNs, and transformers, along with their real-world applications. Deep learning is one of the most exciting technologies of our time, and it continues to shape industries around the world.
If you found this lesson helpful, like the video, subscribe to EduSpot, and turn on notifications. See you in the next lesson.